Most of my career has been about systems, how they behave, how they fail, and how people interact with them. And over the last couple of years, some patterns became hard to ignore. Layoffs were happening everywhere. Tenure wasn't as valuable as before. Adaptability mattered more. Most advice about staying relevant in tech today sounds a bit outdated now. Learn the newest framework, build a side project, update your resume, apply everywhere, wait and hope. That advice probably worked at one point. But after more than 25 years building and running large systems, watching how the market has shifted recently feels incomplete now, especially with AI changing how work actually gets done. I'm Peter. I've been in tech for a little over 25 years, working across Oracle, SAP, and Microsoft. Today, I'm a principal site reliability developer at Oracle, focused on enterprise-scale performance, reliability, and data analysis. So last year, instead of just talking about AI, I decided to build something real. I enrolled in an applied Agentic AI program and built full agentic systems end-to-end. I'll leave a link below that has the program's curriculum and other details if you want to check it out. Later in the video, I'll walk through one of these systems I built. I'll also share the link to the repo if you want to dig into the details yourself. Here's what I want to cover in this video today. First, the 4 things I see consistently being rewarded in the tech market now, especially as AI moves into real production systems. Second, why I chose to formally learn Agentic AI instead of just experimenting on the side. Third, I'll walk through the system I built and the engineering trade-offs behind it. And finally, how I'm thinking about the next phase of my career and what I'd tell anyone feeling uncertain right now. From what I've seen, there are 4 things that matter more than ever. The first is systems thinking. Every tech shift creates a rush to collect tools. New framework, new library, new abstraction. AI is no different. But value doesn't come from knowing more tools. It comes from understanding how systems behave under load, under failure, and under ambiguity. Agentic AI isn't really about clever prompts. It's about orchestration, data quality, failure modes, retries, feedback loops. If you built real systems before, this will feel familiar, just applied in a new context. The second differentiator is domain experience. At a senior level, your past isn't baggage, it's leverage. Whether your background is reliability, data, infrastructure, or enterprise systems, that context makes AI work better, not worse. AI systems don't live in isolation. They live inside workflows, organizations, and constraints. Understanding that environment matters. The third differentiator is communication. Strong engineers don't just ship code. They explain trade-offs, they surface risk, they connect technical decisions to business outcomes. One thing that stood out in the interview Kickstart program was how much emphasis there was on explaining why systems work, not just making them work. That skill matters more as systems get more complex and less transparent. The last and most overlooked factor is having a clear reason why you're learning something. The difference between adapting and burning out usually isn't intelligence, it's clarity. If you don't know why you're learning something, you don't stick with it long enough for it to matter. For me, the reason was simple. I can't control the market, but I can control how I position myself for it. Roles going into 2026 are clearly demanding real AI fluency, not surface-level familiarity. I had 3 requirements from any course that I took. Structure. I didn't have time to wander through disconnected tutorials. Depth. I wanted to build real systems, not just discuss concepts. Practitioners. I wanted instruction from engineers actively working on these problems. The value for me wasn't just the brand, it was being forced to design, implement, and defend real decisions. Interview Kickstart nailed it for me. They had live classes with real Faang engineers, hands-on projects, the whole thing. I built agentic AI applications that I'm generally proud to show off. If you're thinking about making a move and transitioning into higher-paying roles in 2026, check out Interview Kickstart's free webinar first. It is hands down the best way to understand how agentic upskilling applies to your profile, so I suggest you start there. Links in the description. The capstone is the highlight of the course. It forced me to design the system, make trade-offs, and deal with imperfect data and assumptions. You can't fake understanding, and you have to build something end-to-end. I didn't want to build another chatbot that just responds to prompts. I wanted something that looked like a real system, with routing logic, state, tools, and failure modes. That's how Finny AI came together, a multi-agent financial assistant. I'll walk through it by explaining the engineering decisions, not just the features. Let's start with problem framing. Real-world financial planning is messy. You deal with static knowledge, like what is a stock? Dynamic data, like what is Apple trading at right now? And a personalized state, like what's in my portfolio? A single monolithic LLM struggles to handle all 3, hallucinates math, loses track of portfolio state, and can't reliably switch context. My goal wasn't just to make it chat. It was to design an orchestration layer that routes different and tests the specialized components. That's the core behind Agentic AI. I use LangChain and LangGraph to implement a rotor-based architecture. Think of the rotor as the traffic controller. When a user asks a question, the rotor classifies the intent. Add 100K to equities. Go to the portfolio agent. Chart Apple versus Microsoft. Market agent. Can I retire in 10 years? Go to the goals agent. The separation of concerns is critical. It keeps prompts clean and avoids the jack of all trades, master of none failure mode that many AI systems run into. Now let's talk about data sourcing, which is often the hardest part of a serious project. I didn't rely on static CSVs. I integrated Y Finance for live market data, and more importantly, I connected my agents to real tools using the Model Context Protocol, or MCP, via fast MCP. Each agent runs behind its own MCP server. Portfolio tools on port 8005, market data on 8002, charting on 8003. This mirrors the microservices architecture. The agents aren't guessing, they're invoking well-defined atomic functions to fetch prices or update portfolio state. Key differentiator here is state management. The portfolio agent performs atomic updates. If I say add equities and cash, it treats that as a single transaction, not two separate failure-prone steps. If I say add a particular fund, it uses tools to determine that fund's ticker and looks up its asset allocation and allocates the assets appropriately in my portfolio. I also built a goals agent that runs Monte Carlo simulations. It takes the current portfolio state, passes through conversation context, and projects outcomes across the bottom 10%, median 10%, and top 10% scenarios over a horizon you specified, as well as calculating the probability you will hit your goal. This isn't text generation, it's an agent executing a statistical model using the state it actively remembers. Finally, usability matters. I deployed Finny AI using Streamlit, but I ran into a real engineering constraint. Finally, usability matters. I deployed Finny AI using Streamlit, but I ran into a real engineering constraint. Agents generate charts with matplotlib, but LLMs are text-based, so how do you actually deliver images to the user? The solution was to have the tool generate and save the image locally, return only a file name, and let UI handle the rendering. I also added the TTL cache for charts and market data. Market APIs have rate limits, so caching responses for 30 minutes, reduce latency, and avoid the API throttling, a classic systems engineering pattern applied to AI. Is it perfect? No. Right now, the system uses in-memory persistence, so refreshing the browser resets your portfolio. In a production environment, I replaced that with a database for a durable user state. I also chose GPT-4o Mini because it handles structured tool outputs more reliability than Gemini 2.0 Flash for this use case. But Finny AI did exactly what a capstone should do. It forced me to deal with routing logic, state management, latency, and tool integration. It moved me from knowing the syntax to understanding the system. And that's the difference between a tutorial and a project that gets you hired. And that's my project. Through building that system, I became much more comfortable with RAG-based architectures, how MCP fits into agent workflows, frameworks like LangGraph and LangChain, and building more confidently in Python. More importantly, I developed a clear mental model for how these systems fail and how to design around that. After this program, I'm continuing to interview Kickstart's algorithm system design and interview preparation track, because I am determined to stay on top of my career till the very end. No matter which new wave comes in, I'm not standing still. If you're uncertain about the tech market right now, here's what I'd say. Your value never was tied to a specific technology. It comes from your ability to work with others to solve real problems that improve reliability and productivity. Technologies change, that part doesn't. Learning Agentic AI is just another way for me to stay useful. If you want to check out the course that helped me make this project, go click on the link to the free webinar in the description. IK is also giving away a free 90-day AI playbook. Go check that out too. Also, if you want my GitHub project link, comment project link in the comment section and we'll send it to you. Till then, bye.